Alright, jerry-rigging things again. You'd think as an engineer I'd figure out a better way to do this, but here we go. Okay, so this is the first problem in homework number 9 from Webwork. I don't know if you can read it. I have the question here. I'm just going to read it as I do it. So the first part of the question is solve the non-homogeneous differential equation y prime prime equals 6t using t as the independent variable. Part A states, find the most general solution to the associated homogeneous differential equation. Use C1 and C2 in your answer to denote arbitrary constants and enter them as C1 and C2. So part A is pretty simple. All we have to do is look at what is on the right side of this differential equation, which is 6t. And because the highest order of t there is 1, the answer to part A is just going to be a constant times that order of t plus a different constant times the next order of t. So if it had been a higher order of t here, then obviously there would be more constants, but in this case we only need the 2. So for part B, I'm going to write a B here. Using the method of undetermined coefficients, give the form of a particular solution needed to solve this differential equation. Use capital letters A, B, C, etc. for the unknown coefficients, starting with A. So, for this, it's going to be the same kind of thing we did in the last part, except we can't have the orders conflict. So we start with this. We're going to replace the constants with A and B because we know that's what we need to be looking for. And then we know that we can't have the first order of t in this solution because this would conflict with this. They would cancel out and you would get an incorrect answer. So what you have to do is you have to multiply this by the lowest order of t that would not conflict. So in this case, if we multiplied it by just t once, then you would get bt, which is also the same order as 6t. So we have to multiply it by t squared. So you get at cubed plus bt squared. And I'm going to write equals yc and yp here just so we don't get confused. Okay, so now we're going to find a particular solution to this non-homogeneous differential equation. So this is where the method of undetermined coefficients comes in. Basically what I started by doing is I started by writing this again just to make it clearer. And then what I did is I found y prime and y double prime. Well, yp prime and yp double prime. So this is equal to 3at squared plus 2bt, and then this one is equal to 6at plus 2b. Awesome. So now from the beginning we know that yp double prime, well, I guess it's just y double prime, but y double prime is equal to 6t. So having that information, we know that this is the same as 6t plus 0. So we know that 6t is equal to 6at and 2b is equal to 0, which means that a is equal to 1 and b is equal to 0. So if we use that information and we plug that in so that we can find our particular solution up into this equation, what we get is yp equals 1 times t cubed plus 0 times t squared, which is just equal to t cubed. And as you see here, that is the correct answer. The next part of the question states, find the most general solution to the original non-homogeneous differential equation. Use C1 and C2 in your answer to denote arbitrary constants. Note, you could also obtain this general solution in the simple DE by integrating the right-hand side of the DE twice with respect to the variable t. So, for this, what I did is the most general solution to this differential equation is just the sum of the particular solution and the solution. So what we're going to do is we're going to add those to be t cubed plus c1 t plus c2. See, we added yc and yp to get the most general solution of y. We can also integrate, we can try this out as well. We can integrate the right-hand side of the DE twice with respect to t. So what you would do is integrate 6t with respect to t. So first, that would be equal to three t squared plus some constant. We can call it I'm not sure which constant this is, but it doesn't really matter. It's just some constant. We can just call it c1 for now. 3t squared plus c1. And then we're going to integrate that with respect to t as well. And seeing this, we can get t cubed plus c1 t plus c2, which, as you see right here, is the same thing we got before. So that just proves that that gives you the same answer, and that that is the right answer for the most general solution to the original differential equation. Finally, I haven't been labeling these, have I? I'm sorry. What is wrong with me? This was C, and this was D. So, finally, for part E, find the solution to the original non-homogeneous differential equation satisfying the initial conditions y of 0 equals 7, so we're going to write that down, and y prime of 0 equals 1. Okay, so the first thing I'm going to do is write out the equation again, just so that we have that right at our fingertips. C1t plus C2. So you can now, I'm gonna differentiate y to get y prime as well, since we need it, since we have that initial condition. So 3t squared plus C1. So we know that y prime of 0 is equal to 1. And if we plug in 0, we get 3 times 0 squared, which goes to 0, plus C1, which means that C1 is equal to 1. And then we can do y of 0 is equal to 7, which is equal to 0 cubed, which goes to 0, plus C1 times 0, which goes to 0, plus C2, which shows that C2 is equal to 7. And now that we have those two constants, we can plug those into the original equation for y. Y equals t cubed plus C1 we know is 1, so we're just going to write t plus C2, which we know is 7. And there you go. There is the solution satisfying those initial conditions. As you can see, that's the answer we got there too. Awesome. Okay. Thanks for watching, guys.